And we're back. I am Adam Rushford. This is a series, a live stream series intended to teach C++ from someone who knows nothing about code all the way to making your own games and game engine with C++ or anything else you want to do. So, I've got my coffee, or what's left of it, so that you know I'm serious and very professional about this. Coffee. So, we're going to take our time. We're always going to take our time. However, I noticed that the last two streams were a split of a Hello World program, which is the beginning program we learned how to do, and combined, those were an hour and a half long video. That being the case, we're going to go back through it again, like I said we might do, very rapidly this time, and we're going to learn some, and we're going to jump right into it, and I'm going to try to leave a lot of the history. I've already mentioned a lot of the history. We're going to try not to jabber on too much this time, and get straight to coding some stuff. Let me see here. I need to do, I'm not sure. Okay. There's a bit of lag in my cam. That's okay. All right. So let me see what you can see here. Okay. Yeah, that's working. Okay. Because last time when we were running the code, you couldn't see both the console, which actually wasn't the worst part. I was trying to demonstrate the IntelliSense and the auto-completion, and you weren't able to see this, so I'm going to make sure that it's working this time. Oh, I can't. Let me scoot this over a little. There. Okay. Let me just make sure that you can actually see this. Okay, it's not going to work now. So what happened just now was, once you type it like this and you refuse it like that, now it doesn't work. So now you have to delete the whole thing. An easy trick for deleting text, because you're going to have to get real good at like word processing type computer manipulation, is to overwrite text. So what you do is you select the text, and then of course this is the next symbol I want, so I just type that over top of it and overwrite it. I don't bother going through the step of delete and then select my cursor and all that. It's already where I want it. Mostly it's just wrong. You just overwrite the text. Starting over with the autocomplete here, you can see the autocomplete this time. So I hit tab, and that puts in include, because I had already wrote £inc. I know it's very small and you can't really see anything at the moment. We'll work on that in a minute. Let's see here. Let's see. We needed, oh, I just wanted to show the IntelliSense, I think. But I just typed a single double quote. And what it does is it'll bring up every file that your project is in relation to and give you the option for it. And as you type, like, let's just type day, you'll see that there's files that are similar to that. And it's trying to guess, but it can only narrow it down until you finally get one. So let's say we wanted this one. So we'll do date, time. Well, it's messed up now, so we'll restart it. Now we'll do date, time. You see now, all I typed was DAT, and that came up. So if I were to hit tab, auto-completion. There, now I've demonstrated it. Actually, I might want to look into that file. Here, I'll show you something else. You can right-click on that file, and you can go to the document and view it. And this is how you're going to learn what is basically underneath of the code that you code with. And if you can't find it there, like some of the operations, like for example, if you clicked on bool, it wouldn't take you to the code. But you see this one here, it says view code. You can hit view code and you can attempt to. Now you see how bool doesn't do anything. You're going to have to look that up in documents. It's a document called an API. API stands for Application Programming Interface. Application Programming Interface. What it is it's the code interface for other programmers to interface their code or your code with something else. So the API would be where you'd look up things like bool and int and all that. So let me see if I can, we need to make this bigger so it can be seen better. I don't know which one. Okay, I do know which one it is. But it's still not giving me. There we go. Okay. Now we can get this off the screen. Actually, I want to see. Yeah, that'll work. Okay. So, where are we? We were doing an int main. So, like I said, we're going to go back through this real quick. So what you're going to do is you're going to go online with either browser you might happen to have, and you're going to go to choices. Okay, so you're going to go to, why is that popping up again? Oh, anyway. You're going to go to Visual Studio 2022 IDE. AI for coding, yeah. Okay, actually, we're not even going to go to that. We're just going to go straight to downloads. And you're going to get the community version, free download. See that? Doesn't require a credit card or anything. It may require you to register with a name. You can try to cheat it. I don't know if you can or not. But this will be registered to you, and it's kind of important. In other words, if you're going to code with this, you want to use your real information, and you sign up for an account and all that. I mean, we're playing with big boy code here, so this is the real world. So that's what you're going to have to do if you want to use this. Now, there are ways to program without it, but that's not what I'm going to teach you. Because without this IntelliSense and this good compiler and all the functionality that I know how to operate on it, I'm pretty much at a loss as to how to help you myself. So, this is what I recommend. You download this. I'm not exactly sure. We can probably just attempt and maybe get halfway through the installer before I have to back out. Just to kind of show you, before you get started, you need to okay, they need to configure things. So that I almost can't do this. Well, let's see what happens. Just to show you what does happen in modern day when you kind of try to force an error. Okay, so there's an update. It popped up my update, which is interesting. But normally I think what it would do is that you would get a few options. You can just pretty much click continue. You're going to want to watch out for any, I don't think there's any like extra software, but you're going to want to watch out for any obvious things that you don't want. Get rid of that or whatever. I don't think there's really going to be anything. You can just go through that. We're not going to wait on this update because that would probably end up taking too long. So then you'll get it installed. You'll get it installed. You'll get to that screen where you are creating a new project, or you have a solution like this, or maybe nothing at all here. You can create a solution by right-clicking and adding, create a new project. Since I'm here, we're going to actually create both a console app project and in the same. Oh, and you might need to install some things to get these to pop up. They're the default templates, and they come with those. What I showed you in the other video, the other stream. Here, I'll show you. When you get to the installer, it's a separate. They don't give you like a desktop icon for this one. But you can set up your own desktop icon. Get the installer. It comes along with Visual Studio. And right here you can modify, and you can go and you can change the different packages you have, whether it's C#, C++. Because this IDE will actually handle lots of different types of programming. You can do .NET programming, Python, ASP.NET, which is I think older. I don't know. What I'm using is the Linux and embedded development, the game development, not Unreal or any of that. I'm using the mobile, the desktop, the Windows application development, which is C# or C++, because I think there's a different one. And I've got .NET as well. And you may as well install those, because if you're going to code in C++, you're pretty much going to use all that. Any additional ones will be the additional ones, if you know what I mean. Okay, so all that being said, you can get it installed and configured. You get to this point, like I said, or you're just up in here, it opened up and it's just open. This is not the way you want to do it. If you get it like this, probably you should close it, get to this window. You can start with a console app, but we're actually going to add, I'll show you how I did that one more time. I go to the solution, I go to add, because the reason why I go to the solution is, the reason why I go to the solution is because it'll layer it next to this one. Instead of like, if I was to add a project to this, it'll actually nest it within there. So that's not what we want to do. What we want to do is put it in the solution. We want to create a new project. Add a library. You'll find it on this list, just like that. So we're going to add a static library. We can just call it static1 because it's in the solution folder, which is named this. And then that's got another one just like it inside of it, just like this. Now it's going to have one just like this as well. Okay? But you just leave that alone. Go ahead and click create. You never ever want solution in the same directory. Never hit that. That's basically for very specific people. So we're going to create that one. And we're just going to set that aside for now, because we don't need that one yet. We're still going back through the original Hello World tutorial. Let me just get rid of all this confusing mess for anyone who's not seen the other two streams and you're just watching this one. All this green code is what you call a comment. The compiler literally ignores it. This is how you get code out without deleting it. So there are two ways to do it in C++. The first is this, and you get a single line comment. The way that you do multi-lines is to type this character and then an asterisk, and that'll pop up. and you take half of it and you drag that around it. Now that might seem a lot of extra steps, but you used to have to type all this out, and this has been made automated, and it's quite nice in comparison. So, and you can see that a comment within comments doesn't really crippling depression and especially loneliness when you have a PC. C++. Now get started. So let's get rid of all this nonsense. So this is all just a comment. We don't need to worry. Just pretend like this is deleted. None of this exists. All this green is just a ghost. So what our program actually is and we don't really need that either. What it actually is in-out stream. We're going to include this file. Actually, these brackets, rather than these, would mean, in a .h of course, would mean that you're including a single file. This will include all files that it includes. So basically the whole library, which can be bad. When you're including something like IOStream, it's fine to do this. It's optimized in the compiler, etc. But if you were to write your own IOStream, for example, and you were to include it this way, that might actually not be the optimal way. Just to warn you. So you've got to basically check these things. If you want to, code doesn't always have to be perfectly optimized, and leaving a little room to optimize can be a good thing for some applications. Most of the very large ones that you're going to ham on. Mostly very large ones that you're going ham on are the ones that will be all that. Anyway, back to the tutorial. We include IOStream. That is the modern C++ 20 way to use the function count from the standard template library. That's what this std namespace is. It's a call into the namespace to the function count. It's a left shift, which literally shifts over. And don't try to do too many experiments with that. It doesn't quite function how you'd expect. And then a string with a new line, what do you call that? An escaped sequenced character that creates a new line, along with a string that just prints out hello world. And what does it do? It does this. It creates a console and prints hello world to it. And because of the new line, we get this as well. This is the Microsoft Visual Studio Debug console, so it does all of this extra. But if you were to go to where the file is actually created, this is the file we created. Well, both of these are, but this is the only one you'd need to redistribute, and there's a little more that is involved with redistribution. That is essentially your executable now. And when you run it, it will run in the normal console if you don't have this one set to default, which I do. And of course, you're going to have to need a batch file because it doesn't pause on its own like the debug console does, which is what's nice about the debug console. All right. So now we know how to make the basic Hello World program. In fact, when you make a console application in Visual Studio, it's going to give you one. We're going to talk about how to include. That's what the static library is for. But we're going to talk about, well, actually in the other tutorial we talked about variables. So let's talk about that real quick. Variables are like numbers. It's like algebra. It's the conditional changes that you begin with that's basically the configuration of your program. The passing of variables is how you would do multiplication. Variables such as integers, Boolean values, strings, characters, floating point integers, And I can't think of any other types off variable types off the top of my head that are important for a Hello World program. So let's briefly explain them. Integers, you should know this from mathematics. An integer is a whole number. In programming, integers cannot have a floating point decimal. And they represent, you might think, oh, what's the limitation of them? Well, there is a range that they cover. And integers are both negative and positive numbers. A size underscore t is a common replacement for an integer, which is an unsigned long, which is kind of a throwback to C. The size t is actually an unsigned, which starts at 0 and goes upwards. It has an upwards bound. So it just shifts from having negative numbers over to being only positive numbers, but being much, much larger. But they're both generally the same size, I think. And how you manipulate these types and sizes on other systems is called, well, it's related to typecasting, and it has something to do with the configuration. We'll get into types later. But anyway, this type is an integer type, and I'm giving it an algebraic character, and then initializing that character to a value. So that is the integer, and the rest kind of follows suit, except the Boolean can be 0 or 1. It can also be true or false. That's set into the code. Strings can be given an object, and I've got a little demonstration on how that can be used. Floating point decimal numbers are not integers. They can have a remainder or a decimal place. So that is how you work with those types of numbers. And this little f is just an indication to the compiler that this is not two integers with a function between them, but rather one complete number that is a value. And that is actually not always necessary, but it can be with some compilers. So then we get to the main function, the entry point of the program, and you don't exactly need to know what functions are or how they operate just yet to use this one. This is a very special function that is within operating systems to create the entry point, and it is called int main. And I'm going to show you how you can take int main and put that into a library and contain it like a Pokemon in a bottle, okay, or a Pokeball. And we're gonna Pokeball the int main and all of its variant forms, and we're going to create what I call, at least, an entry point library, and show you the basics and just really take control of this whole thing and contain the code the way we want and code the way we want to, and not really necessarily have to conform to the way Windows wants us to code or the way that, I don't know, some open source community might, whatever. But what you'll learn in this process is that things like Java, I feel free to correct me in the comments if I'm wrong, but languages like Java were basically built on this idea, and they were built on the idea that you could create a program and then just write scripts for it, and then just run those. That's basically what Java is. Not to be confused with JavaScript. That is an actual scripting language that's used for web format stuff. We're in desktop land right now. This is C++ in desktop programming. These are variables: the integer, the bool, the string, the float, and the main entry point. Now these right here, these brackets, will create what we call a scope. And this is the scope of the function. This is all the code that is in the function. We're actually declaring a function right here. And we're going to go ahead and, well, actually, let me just show you the part where it prints hello world. We already saw the outcome of that. Okay. And it prints to the console. So we have our own little console. Maybe you've seen these before. Maybe you don't really understand how a console relates to an actual program, but I can get a window that prints some text to that window. But just know this, consoles are mostly used for error code. Well, in modern day they are. This is how computers operated, but there are still pretty much, console programming is still part of the programming. That is the basic Hello World program. Now, let's go a little more advanced. We're going to show you conditional statements. What is a conditional statement? Well, like I said, if we're dealing with algebra and we got x and float y and Boolean lights and myString and all this, we've got these variables. What do we do with them, right? We saw how we could print the string to the screen in the last one, but in this one, what we're going to do is we're going to show you if statements. If statements are a conditional. I'm actually going to release that. Actually, I don't think it likes it. If statements, by the way, the return 0 is part of the int main. It's something that's kind of standard on Linux. Looks like Microsoft just did away with that. You get a warning if you try to use it. So don't, I guess, unless you have a value to return, probably. But anyway, the if statements are conditional statements that basically select different choices based on the variables and the conditions of the program at runtime. For example, if I were to have a console program and it asked the user for a choice and then waited for some condition in which it changed. Like, for example, it took input and it typed Y or N. Okay, so what we have here is our Boolean, I called it lights. And this is going to be, we're pretending that it's a light switch. So if lights equals 0, or I could actually replace this 0 here with false, because false equals 0. I'm trying to show you. Hang on. Maybe if I break the code. Okay, yeah, it just shows false. But anyway, just know that we can look this up later, but just know that that equals 0 and that true would equal false. Or I'm sorry, 1. If the lights equal false, which means to say, okay, in mathematics, equals is different in coding. Equals is what we say in code. Equals is what you say in math. Those two operations are identical. But if you are to say equals in code like this, that is an initialization, or that you're setting a value, as opposed to equating a value. Okay? That's a tough one to remember. Well, not really, but that is something you really need to remember, is that it's not equals false, it's equals false, as in, does this equal false? Whereas if I say equals false, that means I want to set x to the value. In other words, I'm literally almost like a wizard. I'm saying it equals this. Because, well, we're wizards now, Harry. So, what happens if lights equal false? And you'll notice that if statements are actually conditional statements of different types, are in different programming languages. So that's how they relate with conditional statements. That's what they'll always be called. There is a computer science theorem on all but you could, I guess, read somewhere. But but I don't think most people, this is kind of like Wild West seat of your pants. I'm autodidactic. You're going to be autodidactic if you learn from this. This is the world of programming. Welcome to it. So, what is the else if? And I actually set up this whole complex if, else if, and else to show you something really interesting about this whole setup and about scope. That's why it was related to me talking about the scope. So, what does it do? It prints out here, it prints out there, and it prints out here. These are all separate conditions. Only one of these will be printed to the console, given the conditions that take place. Now, if the lights equal false, well, we did set it to false up here when we initialized it. When we first created it, we set it to false by saying equals false rather than just doing this, which is a possibility. But then we don't know what lights initially is. It could be true or false. So we set it to false. That's the initial condition that we desire at the moment, which may change, and we can change the code. That's how this works. It has the power. So if lights equal false, in other words, if lights are equal to false, then we're going to print out the string light turned space, and then we're going to left shift even more string onto that string, which is on, and it's going to attach itself to the end of this string, and then we're going to finally use that escape charactered n to create a new line in the console. And there's another way to do that we're just going to demonstrate. We can left shift the standard end line. This is the way it used to be done. This is not the way you want to do it now, but it can help to make code a little more readable or concise at times. This is kind of hiding here, but it's actually inserting the string in there as well. Basically, like a stack of books, we're just using left shift and stacking it right on top of each other, and then we get a new line at the end, so it just goes on to the new line. So let's see that in practice. Light turned on. See that? Now the lights are equal to false. So basically, I wrote that wrong. It's because I wasn't paying attention to the outcome of the, I was busy writing it out so that I didn't have to write it as we did this. So we'll just make that quick correction, and then you'll see that the lights initially start off, and that we do get the new line in there as well. So, what is the rest of this code doing then, Adam? It's just junk? No, it's not junk. It's conditional, meaning it never fired because this one fired. And, well, that's actually not true. It does get this far. But the reason why this code didn't fire and this other code didn't fire is because, well, first, let's simplify this a little bit better. This is your basic if-else. So you'd have off and on. Now, if the lights are equal to false, then it's going to turn off, or it's going to say it's off. Else becomes apparent what that does now, right? It means that if this one fails, or this isn't true, this whole condition doesn't equate to true, ultimately, regardless of true or false it says here, it has bearing on it, but it's not what I'm talking about when I say the condition equates to true. What I mean is that the logic all equates to literally either 0 or 1, or 0 or a non-zero number. We'll get into that a little deeper as we go. But what you need to know for now is that we're working mostly with 0 or 1, which is basically true or false, especially when we're talking about Boolean values, at least in the beginning. So because this function fires, well, it's not a function, it's a conditional statement, but it kind of operates like a function. You notice it sort of looks like one. It has its own scope like one does, at least, and this is the scope that fires when this condition equates to true. not paying attention to this part when I say that. Otherwise, else, this one does. So if I was to put true here, you'd think that this one either just wouldn't fire, or it'll just fire it anyway, right? Well, it actually does what I say it does. It goes through the else statement, which doesn't need any more conditional because the conditional of it is part of the if. Okay? So now it equates to light is on. This failed because it's false. It's not true, so it doesn't equal true, which causes a zero condition or a false condition and gives you the other one. Now, how does that work if there's three of them? Let's put this one back in. Now we have what's called the else if. Well, what's really interesting, this is the really interesting thing that I've never seen in a tutorial ever that I really wanted to share with you guys. I find this just absolutely fascinating. It's a function or a conditional statement that actually uses the scope of the program itself to layer itself in a optimized pattern in which this is actually just an if else with another if. Isn't that interesting? Because the very first line up to the first line after the else, it will fire that line of code. So, if the if is either here on this, or it's still on the remaining line, it'll just fire like a normal if statement. Clever, isn't it? I didn't come up with it, but it's damn genius. So anyway, that's the scope trick of the if, else if, and else statement, or the if and else if statement, if you prefer. So what's happening here is the else if, or rather the else, equated to, because if you use else if rather than another if statement, which you can do, code is very versatile. You can pretty much do any combination. I say that very reserved. So what it's doing is it's creating a whole new if statement, and the reason why this one even gets a chance to fire is if this one first fails. Okay? Otherwise, it's not going to do this one at all, which means that it's not going to report an error if it's off. Okay? So if it's off, so not if, right? Or we're not going to do this one because it's not true. We're going to go to this one because else, and then we got another if. So lights not equal 0 and lights not equal 1. What does that mean? Okay, like I said, Booleans are usually 0 or 1. But they can be non-zero numbers like -1. Well, I don't know if a Boolean can actually be negative. I don't think it can. At least not in C++20. But it can be 2. Well, no, sorry, it can't. But it can be in a form like, say, a pointer or an integer passed to this by mistake, and it could get 2 or -1 or any other value that's not 0 or 1. So in the case that it's ever that way, which may not actually be possible in this scenario, but just to show you, to demonstrate the else if, because I didn't know what else to really put in here. Okay, so that's why this is here. But I wanted to show you another condition concerning the lights or the Boolean that you might actually, like a real world scenario, even though this isn't particularly a real world scenario. You might have a value or a condition here that uses lights, and then you might have a value or a condition here that also concerns the lights, like an error condition, just like that. This could be a real world value if it wasn't for the fact that you're using a Boolean right here, and that Boolean can't really go. This part is the wrong part because Booleans can't really do that. But if lights somehow got changed in value, if it picked up an integer named lights, for example, somewhere in the code, then yeah, it would throw an error, and it would work real world scenario. As far as strings go, in the string here, I noticed that I was reusing this part. This is something you're going to do a lot in C++, is try to reuse all your code, which can be bad, by the way. And we'll go through that someday. The light turned with a space is just the prefix of what would be here. So we're just using that string and putting it in there to show you that you can mix string objects and actual strings, or I guess you would call it a literal string right here. Okay? So that is the demonstration. I think I'm going to cut this one short because I don't want these to run an hour each just for quick Hello World tutorials. But that is the complete Hello World tutorial, how to get the VS 2022 Community Edition installed. Open up your first console application. Well, we did show you how to make the static lib as well, but we didn't do anything with it yet. Showed you the variables and how to get started with those a little bit. We showed you how to use those in conditional if statements, all in C++ in a Hello World program. And in fact, let's see if we can try to create that real world condition. Like, we'll just say that lights equal 2. We'll see what happens. Okay, wonderful, wonderful. Okay, so it says light turned off. We didn't get an error. Okay, and this is what code's going to do to you a lot. It's going to do things that you didn't expect. And what happens if it breaks the computer, Adam? Okay, so that's what this IDE and this compiler is for. It is to catch errors and warnings about your code so that when you start to drift a little too far off that path of what's safe, this kind of reins you in and it prevents you from damaging your computer by causing an error, and it won't actually build. And then you have to go through and figure out, you have to read the information, figure out your errors, correct them, and then you can try to recompile again, which of course each time you would want to right click and clean so that you make sure you delete all those extra junk files, the executable, everything gets wiped out so that you can perform a nice clean and won't have any errors in it from the actual build process itself. Man, that pretty much covers everything for this first short stream, or third short stream. This way you don't have to go and watch that hour and a half stream I did, or 2 streams before this one. You can skip right over those because we just covered everything that's in those plus the if statements. But we're going to stop this one for now. And then we're going to do another one. We're going to do, I believe we'll do loops next. And we'll show a main loop and maybe even time and get into timing, maybe talk about it, maybe not a full demonstration on that one because I might need to get a little more prepared. Timing is a big, important, complex, difficult subject, even though it's going to probably be one of the smallest files in your set of code in pretty much every program, which is ironic, but irony is rich in programming, especially C++, so get used to that. What else? Also, I want to say, I'm not begging for subscriptions, but if you want it to be easier on you to follow along with this, because like I said, we're going from not knowing how to program at all, make a game engine, make your own games with C++. So if you want notifications on that, subscribe, get your notifications, turn on the all-time what is it? I can't remember what they call it. But turn on the notification bell however you like it, and follow along. And you won't miss any of these. And you can stick with me, and we can do this quickly. and we can turn you all into a massive army of programmers to make video games for your enjoyment, for my enjoyment, for the world's enjoyment, and make the world a happier place. And my name is Adam Rushford. It's been a pleasure to try to help people with my knowledge, which seems to be kind of like, it's almost like C++ is fading away. And that's part of the reason I'm doing this, is to prevent C++ knowledge from slipping beneath the cracks of a direct source for autodidacts like ourselves to educate ourselves without having to go buy a bunch of books, without having to go to the library, and waste a bunch of time in our lives just because we want to make games, right? We want to make games, and we need a lot of building blocks and stepping stones to get there, because you can't have a public access television without somewhere for the public to perform on stage and have a camera, right? So I'm going to give you the stage and camera, and you're going to take it from there. So hit the subs, hit the notifications, follow along, and I will make you at least a half decent, competent C++ coder by the end of this, and we can all enjoy our lives. And happy ending for everyone. Isn't it great? That's what I offer. So follow along, and of course, always, happy coding.